Cool. It's not it. This is it. Like this. Should have gone with the bigger form factor, huh? Maybe I can just change that on the spot. I doubt it. Guess I'll just stick with it. Hi, I'm gonna get off of my, I prefer to talk while standing, so now that we've got this thing working, I'll just get going. We're recording, we're screen sharing. I'm Thompson Comer. Thank you very much for all getting up early on this last day of Denver Startup Week to come to my talk about remote logging. I am certain that you will be in fan of remote logging by the time I'm done with this talk as well. And if you're working in development in Internet of Things or mobile or server, you'll be glad that you attended this talk because you will become a better developer as a result. Presently, I am the lead computer science instructor at Lambda School, which is a startup boot camp that changes the boot camp model in the sense that it is, well, I'll get to that. I have a slide about Lambda School. You can reach me on Twitter. You can reach me on LinkedIn. I'm really glad to be here for Denver Startup Week. You know, thanks Connor and Jay for putting this whole thing together. They requested that all the presenters give mad props to our many sponsors. So here they are. The title sponsors like Comcast and my friend Ben Massander, who's running the Viper Group up at Comcast now. WeWork, Chase for Business. I don't know who Aging 2.0 is, and Downtown Denver Partnership, but thanks you guys. Track sponsors are the sponsors that contributed to building each development track. Fanatics is the developer track sponsor, which is what this talk is. So funding for this building, funding for this conference room today, and for this TV. Thanks Fanatics. Fanatics makes high-end sports apparel. And they're actually hiring in Denver. I see them all the time, hiring software engineering roles, server and front end and back end. And then we also have a long list of headline partner member sponsors. Please do business with them. It's unbelievable that we can put on a conference that has presumably 18,000 attendees all over downtown Denver today. So exciting to be at Denver Startup Week. This is the only day that I'm able to attend. I live an hour away, and this has been my second week at Lambda School full-time, so I've been way too busy to play. I want to talk about Lambda School for a few minutes. This is my new gig. I've been here for slightly under a month at this point. I essentially started at the beginning of September, having left a 7-year consulting engineering job to teach. And I've been watching boot camps out of the corner of my eye ever since I finished graduate school. I was like, you know, engineering's great, but it'll always be making rich bankers richer, generally. Somebody's going to come to you and say, I have a huge pile of money and I want to build something cool. I'm going to give you a share of my huge pile of money and maybe I'll get a huger pile of money. I shared with my CEO at Lambda School a tweet that I saw on like Wednesday or Tuesday that struck home for me, and I've seen it before getting passed around in the meme circles. It's called ikigai. It's a Japanese word relating to work that's an intersection of what you love, what you're good at, what you can get paid for, and what is meaningfully contributing to the world. And for me, teaching at Lambda School is my ikigai. I actually get the chance to give presentations like this like 4 times a week, more or less, which makes me sweat bullets compared to engineering. Engineering, I can take my sweet time. I don't have to be right. I can just kind of, I'll tell the client when I'm right. Whereas with having to teach students, having to teach you guys, I need to be right now. So it's quite a bit more pressure than engineering is. So, I mean, there it is. This is kind of our front page. We're a very early startup. We went through Y Combinator. We successfully have funded A-round funding. I don't know all the technologies and the financial models behind startups, and I don't really care. I like engineering, I like building cool technology, and I like teaching. So this is an opportunity for my bosses, Ben and Austin at Lambda School, to do that work, to run the company and to figure out how much money we have. Supposedly we have enough millions of dollars in VC funding now that I can work at Lambda School for 3 years. And that'll give me the chance to build all kinds of curriculum stuff that matters, like teaching students log all the things, among other things. Before I move on, I have one more thing that I want to say about Lambda School. The reason that I titled the slide Hyperbolic Education, because everybody says, you know, why Lambda School? It's just another boot camp, right? It's just another startup. And I pause just like this and I think about it for a minute. I go, okay, well, I'm gonna challenge you with a hyperbolic statement. It's a verbal demarcation line, and I'm gonna make you submit to it. And that is, the future of education is free and online. And everybody goes, yeah. And I've done that to 15 people. Why did I go to Lambda School? Because the future of education is free and online. And they all go, yeah. And nobody's ever disagreed. So it feels like it's a good business decision. Finally, I want to give props to my former employer, Cardinal Peak, whom I left essentially 1 month ago. Cardinal Peak's a contract consulting firm. We work in IoT, or they work in IoT. We work in mobile. They work in server spaces. And in the 7 years that I've been a consultant for Cardinal Peak, I've worked on about 9 different startup projects for big companies and for little companies. I've done truly full stack. I've done firmware engineering. I've done artificial intelligence, computer vision, mobile design, and so on. And if you need IoT work, if you need mobile apps, Cardinal Peak is located up in Lafayette. It's full of geniuses. They knock it out of the park. If you're looking for work, apply. Thanks, Cardinal Peak. All right. We made it through the welcome. I'm going to take a breath and keep the caffeine flowing. I have to keep the caffeine flowing because I have to take my son on a 30-minute long drive to school every morning at 6 o'clock. And then Lambda School doesn't even get out until 7 p.m. So I work like a 17-hour day, or a 13-hour day. I wake up, I work a 13-hour day, and then I eat and put my kids to bed. So I'm doing like 5 to 6 cups of potent coffee at all times. Log all the things, the table of contents. We went through welcome. So the first thing I want to tell you about is the history of debug. Why should you log all the things, and why is it important? I'm going to go through all the technologies that I know of that have been used for debugging software over time, and why they are all deprecated, except for logging all the things. Once I'm finished telling you about the history of logging, I'm going to tell you why logging is foundationally the only way that you can debug your code on the Internet of Things. Once that's finished, along with that, I'll say why logging wins, period. It doesn't just win on Internet of Things, but it wins in every context of debugging and software state management. Once I've gone through kind of like why you should log and arguments that you can use against people who say we shouldn't log, I'll tell you how to log on multiple hardware platforms. And I'm talking about how do you write mobile remote logging? How do you write firmware-based remote logging? How do you write server-based remote logging? And some of the getchas and stuff that you've got to think about in order to be successful. Along with that, I'm gonna reference a company that I'm a big fan of, Loggly, who essentially exposed me to this entire technology field of remote logging and has changed the way that I develop and has made a humongous difference. And then finally, I made a little demo product. It's sloppy. It didn't get as far as I wanted because I started a new job a month ago and didn't have time to make it perfect. But I'll show you essentially a virtualized Internet of Things environment. And I'll show you how you can use Loggly and remote logging to know what the whole environment is doing instead of going, how do we figure out what's wrong with this device versus this device? You go into this remote logging store and you see it all. Finally, I'll take questions. So the history of debugging started with the core dump. And you can still use core dumps. They're disabled on OS X by default because they're useless. They weren't useless in 1950. Okay, the first object, well, let me just give you the quick rundown because I'm an academic. I always tell you what I'm going to tell you, and then I tell you, and then I tell you what I told you because I believe that's what you need in order to really remember what we went over. So core dumps, that was the first thing. Stack traces, that was the second thing. Before stack traces, all there was core dumps. And then the next technology they invented was a stack, so they could debug the stack. That's helpful. Logging came in immediately thereafter that and fell by the wayside, right? For the last 15 years of my career, people kind of knock on logging. They're like, you can't debug a program with logging. That's like the caveman approach. My IDE gives me great power using step-through debug, and I can just reflect inside of my code and see what the problem is, which I'm going to argue isn't actually useful anymore. It had a very nice heyday. If you work within a specific domain with a super powerful IDE with a very limited domain where you have to work, still very effective. State replication involves taking some remote machine, figuring out what its state used to be, copying it to your local machine, and then trying to debug it, right? Because you don't have that state, it's gone. It's on my phone. This is the code that I write. It's on your phone. I can't debug it when a crash occurs. Remote analytics is the latest technology. I think before remote logging has really gained traction. Remote analytics is kind of remote logging, except another company has provided you with the API that you're going to use. They're going to tell you what you can debug using their remote analytics. And then finally, I'll talk for a long time about how cool logging is. So this is a core dump. In 1950, a computer, right, was 3 stories of this classroom. And it had individual transistor elements that were, you know, half as big as my water bottle plugged into the wall with wires going everywhere. And it had a single execution frame, and it had like a punch card or something like that, right? So an engineer would meticulously build his program on this punch card or some other way of communicating with this machine, and then they'd run one thing. It wasn't a multi-user system. It ran the program that you gave it, and guys would literally like reboot the system with a power switch this big, thunk, thunk, before they put the punch card in. And after they ran the punch card through, a number might come out, right? They put the punch card in and the machine would hum. And they go, did the ticker tape print yet? No, the ticker tape was supposed to have printed by now. And they're like, well, that means that something was wrong in my program. And so they go physically observe the state of the machine. They pull wires and measure their current and say, oh, here's where the program bug was, because we knew that this particular memory address, that's supposed to be a C, George. How could you do that in your program? And so you change your punch card and reprint it. You could still use that today, and it's still useful if you're doing certain kinds of assembly programming. You can still utilize a core dump. But all it is the memory space of the entire program that you're running. So if Google Chrome crashes, the core dump is, you know, 7.5 gigs. Like, you can't use it for meaningful reflection. Stack tracing is the next important technology for debugging your code. And stack tracing essentially just shows you every responsible frame of execution that led up to some problem that you want to track. You can use this remotely. If you have a machine that suffers an error, it can capture its own stack trace and dump it. But 90% of the time, so I like to look at this one and say, okay, where's the problem? Hello world layer init, that's my code. Hello world layer scene, that's my code. App delegate application did finishing launching, that's my code. So those things are useful to me. But all this other stuff, especially today when we're literally talking like 100 million lines of code involved in all those other stack frames, are intense signal to noise ratio that don't contribute to my understanding of my own programming flaws. That's my goal, right? I wrote some code, it has a bug in it. It always has a bug in it. How can I fix those bugs using feedback from the machine? And then in the worst case, which is also exceedingly common, none of your code appears in the stack trace. And it says, oh, the program took a dump because you forgot to put a curly brace in there somewhere, and good luck finding it, because stack tracing is not going to reveal the issue to you. Console logging, like I said, it's actually my favorite form of debug, because this whole conversation is about remote logging. I don't even want a console log. I want a meta console log. I want to log all the consoles all the time. But in a local context, it's easy to get it wrong, okay? It's something that really has to be executed properly, and it's especially meaningful in remote logging. It's less meaningful locally, which is kind of an example here. People get console logging wrong, and they laugh about it, and they say, oh, I ran somebody else's program, and it said, you know, 14,000 repeat loops of, I checked the node and then I went to the next node. It's not informative. You have to write it with care. Your logging is, in fact, it's not as important as the code that you write, but it's probably more important than the documentation that you write. So you write the code, then you write the logs, then you write the docs in some sense. Okay, so you have to be careful about what you build, and you can get it wrong. More importantly, this is meaningless outside of the context of all the other systems that are involved in this pipeline. And it's exceedingly rare today that any of us get to write code that runs on your computer, produces a result, and that's the deliverable. Like, high five, team, we did it. That's not how it works. You write code, you send it somewhere else. It integrates with 10,000 other computers and the results come. So remote logging is about integrating all of these logs together. Step-through debug was the knight in shining armor of debug for 15 years or so, I think. And I'm not a huge fan of it. Primarily, I'm not a huge fan of it because it requires access to the local machine, which you simply don't have. You know, we're mobile developers now. We are IRT developers. We are microservices developers. And just because you found a bug when you were testing the code in your local environment doesn't mean that you're going to cover all the bugs that are going to happen in the real world. And when that bug happens in the real world, you don't get to stack trace it. You don't get to pause execution and figure out what's wrong. Finally, I just have to take a knock at Eclipse. The reason that this became popular, the reason that step-through debug is so huge is because about 15 or 20 years ago, some guys wrote this IDE that did your programming for you, and it knew everything about every object that you made, and it would suggest what method you should write next, and it would tell you what template to put in your file, and it would debug your code for you too. And I think that that was actually among many of the philosophical challenges that Java brought into software development that limited our ability to become better programmers, because you can't actually depend on your tools. Your tools don't know what it is you're trying to write. The hard part about programming isn't connecting your symbols together. It's building a group of symbols that solves a problem, and Eclipse doesn't do that for you. State replication. This is kind of meta debug, okay? If you encounter a problem in the field, and you will, your CEO will call you and say, I had a bug on my own device. Your customer will call you and say, I had a friend who had a bug on their device and I feel embarrassed, okay? And so then you tell your developers, how do we fix this bug? Somebody had it on their phone and we don't even know what they were doing. And they go, we have to reproduce the state that their phone was in. We'll set up all the databases. So they have production database and we'll run it on our local machine. Listen, even if you can perfectly recreate your production state, you can't reproduce the state of your customer's machine. You can't reproduce their power up down state. You can't reproduce their cache state. And so state replication gives you the illusion that you're debugging, you're solving bugs in production. But the reality is there's a huge amount of metastate wrapped around your database and your web application or your mobile application that you, not only can you not reproduce it, you can never even know what it was. It's just hundreds of millions of ones and zeros that are not reproducible. So state replication doesn't solve your debugging issues either. So I have to have this final slide here. I'm not a genius with any form of analytics, but there are some great analytics companies out there, New Relic and Datadog and Crashlytics and many more that I don't even know, who build a really cool remote API that you plug your application into and you connect it to their service with either software that they've written for you or HTTP calls that they've provided for you or WebSockets. And they give you reflection into your online software health. And they can tell you how many devices have crashed. They can tell you how many devices are up and down. They have they can tell you how many devices called which method got called how many times. Those are cool technologies. And I'm sure that there's tremendous gains to be had there. But I mostly back away from them because you have to buy in to a single API to really benefit from it first, which means like you can take 6 months of your educational space and dedicate it to memorizing how Datadog's APIs work and looking at their protocols and writing all your software so that it's Datadog software. And then if your next customer comes along and says, dude, like, you know, the CEO of Datadog is my arch nemesis from high school. We can't use Datadog. You know, just get another job. Like it's hopeless. You can't take the 6 months that you gained in Datadog API benefit and point it at a new analytics server like that. So with remote logging, you're going to build your own analytics, essentially. And you're going to build it as string pipes, which is what the philosophy of Linux is. And it'll work better for you in the long run. All right, so that gets me to the good stuff. Like, I'm done telling you why you can't use all the other debug methods. Now I want to tell you why you should use remote logging, and you should start every project from the philosophy that if I remote log this, I will have far fewer defects, and I will deliver the product more quickly, and I will have more confidence in the product. You know, why should you use remote logging? You can't stack trace. You can't do it. Your CEO calls you, I have a bug. You're not stack tracing that. You don't want to look into the future and build a new state replication and then hope that you can find the CEO's bug. You want to say, I will fix your bug, the one you just called me about that's in the past. You rebooted your phone, that's fine. I will still fix your bug, okay? Like I said, repeating a bug made up in a made-up environment, it doesn't pay off. It doesn't get you there. Sometimes it does. Sometimes it's just another like checkbox. Not the solution, not the solution. We'll get to that in a minute. Loggly makes that super easy, and I super highly recommend these guys. I think this is my favorite slide in the presentation because it embodies why I'm so passionate about remote logging. Because it came from my professional career. I did not discover Loggly in my team. I joined a product that we had been working on for a few years called Yonder. That's a competitor for Spotify. And it's really interesting, okay, Adam Kidron is the CEO of Yonder, and it's a Spotify that you can purchase in like the Philippines now. They have lost the market share in the US. They will not be gaining the market share in the US. They don't even have licensing to do Spotify in the US. They have to do Spotify in foreign countries. But Adam Kidron was the CEO of a company called Beyond Oblivion that you may have heard of way back in like 2008. And Adam invented Spotify before there was Beats Music or before there was Spotify. And he blew dozens of millions of dollars in startup money trying to invent Spotify, and the world wasn't ready for it. Okay, the reason that Beyond Oblivion failed is because Adam didn't have the market connections to get Sony to share all their music with, right? That's the hard part about writing Spotify. It's not about sharing the music. It's about knowing the person that will allow you to download hundreds of gigabytes of music from Sony. Anyway, it's tangential, but my colleagues were using Loggly on the Spotify team, or rather the Yonder team, and I saw it, and my heart became inflamed, and I realized that this was the tool that turned me from the caveman debugging, because I was always a fan of console debugging, and I never used stat through debug because I was writing C programs and running them on remote machines, and it just didn't benefit me. And when they showed me Loggly, I said, wow, like this is actually how you fix bugs. This is actually how you satisfy your customer. I still want to talk about Yonder for a minute because I have an anecdote that I absolutely delight in sharing, right? Because Beyond Oblivion failed because of licensing restrictions. It's too hard to find the right person at Sony who will share with you the entire Sony Media music library. By the time Yonder came around, so Beyond Oblivion was the first pass, Yonder was the second pass. Yonder succeeded because those engines had already been built. The people who had the right connections got the Sony marketing machine to share their music. And so while we were building Yonder, Sony mailed us about 14 3-terabyte hard drives with the entire Sony music licensure on it, every single song in WAV format. And we copied them to Amazon Web Services so that we could stream them down to people. The anecdote is that I remember seeing all those hard drives in boxes sitting on the table, and I went like, wow, that looks like lifetime in a political prison, right? Take all those hard drives, take them home and sell them on eBay. No one will ever hear from you again. You'll disappear off the face of the earth. That's the anecdote. I had to say it. Okay, so I like this picture here because it looks like a petri dish and it's full of dead bugs. And remote logging has enabled me to kill bugs in a way that, and I don't mean this to be rude to any of my colleagues or exaggerate, but to make other developers look like they're amateurs. Because I don't answer the phone and say, and that's what the rest of this conversation is about, okay? Here's the boss. I'm on my phone and I'm trying to play this song and it says 32567, programmer error to blame. Who's responsible for this? Like, I'm trying to ship this to Sony tomorrow, and this is what I see on my phone. This is before you have remote logging. And you go, I'm going to dedicate all my resources to it, boss. I promise I'll figure it out, right? And then you go and you sit in front of your machine and you type and you search and you try to figure it out. And gosh, what could be the problem? Is it on line 75? Is it in this file, in this file? I'm scared. I really want to solve this, okay? And then, I mean, obviously these guys are developers because they have beards. And this is me now with remote logging because my experience with fixing bugs in production or in staging right before the most important investigator on the project gets to see it has gone from, shit, I'm flawed. I'm a flawed human, right? We are, and we always write software with bugs. But now when I get that call, I say, okay, I'm sorry that you encountered that. Stay on the line with me. I'm logging in to Loggly now. Tell me your device ID again. It's ABCD12345. Okay, I'm looking at your logs. Oh, and you can reproduce the bug? Okay, well, I see your machine now. Like, why don't you reproduce the bug for me? Okay, I'm refreshing because it takes a little bit of time. Okay, I see. It says it had an error, and the error happened because the output data from the server is lacking a string that they said was in the API. And so I'll call them and tell them to fix it. And it'll be fixed in like 10 minutes. We'll make another build for you. Click. And so it goes from this amorphous hell of fixing bugs where somebody says, you wrote a program and you don't know everything that it does, to I don't know everything that my program does, but I asked it to tell me what it was doing so that I can look back and fix it on the spot. It works in real time, and it's taken me from the man who goes, oh, I feel frightened even remembering that sensation of having a bug in production, to going like, yep, oh, I found that for you already, you're good to go. I took this slide. I get all of my image assets from Google Image Search Creative Commons licensing, right? So it's all free open source images. This one had a tag that said, I want to be cited. And I thought it so perfectly met what I'm trying to talk about here that I had to have it. And this is fixing a bug. Is it a sprint task or is it a maintenance item? And what's the difference between them? And this is an agile reference because I really hope you're doing agile development. If you work in a group, if you have principal investigators who are not you, who are telling you what should be built, then you need to have a sprint planning. You need to define what you're going to work on, and you need to gamify it because otherwise you're shouting in the dark. Now, I'm not a proponent of any particular agile methodology, and this image is just right for that. Don't do cargo cult agile development, period. There is no proper agile methodology that's going to make your code work. It's simply that every once in a while, you itemize what has to be done, you throw away everything else, you discuss the importance of those things, and then you gamify them so that you can deliver them. And if you don't do that as a developer, you're just going to be, well, you're going to be, and I don't mean this any more rudely than it sounds, you're going to be vanity developer, where you're writing code because you like writing code and you made some stuff because it suited you this week. And honestly, I just don't even like coding that way at all. Being agile is being able to identify a task, okay? And when you get a bug report and you're not using remote logging, here's how it comes. On Tuesday, you're coding away, you're putting together some kind of demo, you want to tell your friends about all the cool things that you built in the last sprint. And then on Wednesday, you come to the sprint planning meeting and your project manager or your CEO or your client comes in and says, you know, Jira task 555 says that the software sucks and something bad happened. And we thought you were cool yesterday, and today we had what I wanted to say was we had this list of cool new features to work on. But today, we don't want to work on any cool new features. We want you to use all week, 2 weeks, just figuring out why 555 happens, because nobody knows. You don't know. It might take 2 weeks, and if you can't figure it out, you can take the next 2 weeks to figure it out. Like, just keep on studying that bug and crying about it until the problem goes away. If you don't have remote logging, that's what you're going to do. You're going to start off and be like, what's my forensics? How do I determine what the client was doing when they caused the issue? And then how do I replicate the state? And how do I trace the stack? And on it goes. A maintenance item is they call you on the phone and say, hey, I just made this sprint item 5555 that says your software sucks. Oh yeah, I looked that up online as soon as you created it because I got an email notification and I fixed it before you even called me on the phone. I'm going to work on cool stuff next week, not bug fixes. All right, so I made this slide because I love complicated flow charts. And I want you to imagine that what you're really building has a ... with another one of these symbols for each of them, right? There's apps with a ... and then apps, and how big is N? I don't know. It could be 100,000. How big is things? ... Hopefully it's 100,000, right? Because otherwise your thing company goes on. How many servers do you have? It's probably not 100,000. Maybe it's only 30 servers that are responsible for spinning up 100,000 microservices, Lambda instances. Okay, so think back to the one slide ago. You know, I had a bug on 5555. Which one of these boxes is responsible for it? Which one of these n times m times n times n boxes is responsible for it? Put all that data into a remote logging service so that you can find it, right? Because this is where we are today. You cannot stack trace. You cannot core dump. Those days are gone. There's a new methodology, and you have to think about it. It's the second step that you do after programming. First you program it, then you report the state to the remote system. All right, and I'm sorry I haven't even told you how to do this yet, but I love to talk about, like, yay, logging! I cheer for it for an hour before I actually say what to do. This is the last slide about how cool logging is, and I'll actually tell you how to do it. Because I've had to argue about this a lot. And the first line of resistance is always a question of security. And I don't have a perfect answer. I go like this when somebody says, well, what about security? I go, you're wrong. That's the only answer I can come up with, essentially. So Loggly, the service that I'm going to suggest that you use, they're HIPAA certified, right? They already have, I don't know, I'm going to hyperbolize and say $150 billion worth of companies using their service now, trusting them to keep their data safe. They're HIPAA certified. They have HIPAA companies pushing patient medical data into them. So don't tell me they're not secure. You can't write a system that is more secure than Loggly will write. You can pay your engineers 300 grand for 3 years to build it, and their system will fail and be like Equifax. Loggly will not fail, probably, because they have a team of great security engineers making sure that your data is safe at rest. This is another one of my pitches I love to get into. Your data is safe at Loggly at rest. It's all encrypted, decrypts it when it reads it for you. No one can access it. Now your data in motion, it's safe too. No one can read it at all except for the NSA. And so you shouldn't worry about it. I mean, you know, the data in motion is compromised. And as long as the NSA isn't reading it while it's in motion, then you're still secure. However, we do have to have some care there. Well, we don't want to log HIPAA type information as much as we can unless you need it. Don't log people's names. You can put a flag in there that says if you see a name field go by, throw it away. Don't log people's personal addresses unless your product depends on it, right? If you're debugging, if your ability to deliver a working product depends on names and addresses, log them, because that's what you're selling. You're not selling like private security, keeping people's secret data secure. That's already, Equifax already dumped it. Don't worry about it. Rather worry about building a great product. Finally, Loggly has really limited access control lists, okay? So on an expensive Loggly tier, only 5 people can log in and read that data anyway. So as long as you ensure that you have the right people with access, it doesn't really matter what you log. One more thing to be careful about in security that I've done personally repeatedly is don't log people's Wi-Fi passwords, because you're gonna have them. Especially if you're doing IoT. You're going to read their Wi-Fi password and you're going to hand it to another machine. And someday I'll figure out how to stop doing that. Your boss will also say, can't we just roll our own? This is so simple. Why do we have to pay Loggly hundreds of dollars a month? Can't we just make it up our own? It's like, do you realize how much you pay me? How many weeks do you want me to spend on this making a shoddy, low-end version of what we can get for Loggly that's going to cover, and I've tried to work up numbers, but once I really get going in a presentation, all the numbers go out of my brain and the words come out. Imagine that you take 3 weeks to build a really crappy text dump that you put on a server, and you can grep the files. You can log whatever you want to them, and you can grep them. Okay, so you just spent, let's say, a developer $1,000 a day. So you spent $15,000 taking 3 weeks to build a crappy little text dump that will need to be rebooted and need constant maintenance. The most expensive tier of Loggly I've ever seen is about $1,000 a month. And that was for something like 15 gigs of daily logging and 4 weeks of retention, an incredibly powerful search service, security, access control lists. And so that's 15 months. Okay, so to have a developer build a crappy log service for 3 weeks costs as much as 15 months of Loggly solving all the bugs in your program for you, essentially, like which is more valuable. And then finally, bandwidth, because I'm, well, as you know, I can talk and talk. What time is it? 10:42, I have ample time. I should slow down and take another drink of water, actually. Pardon me. Bandwidth. Bandwidth is something that firmware engineers always get uppity with me about. And I'm like, log your computer. Like, we could have fixed that bug if you would have been logging it, George. And they're like, oh, but think about all the bandwidth. What are you talking about? Like, the whole world is bandwidth. How much is my machine logging now? Like, how much network traffic is my machine doing just sitting here on Galvanize's network? Like, who wants to take a stab at that? It's hard to say. I have 30 browser windows open. So like 60 KB a second? I don't know. Like, what's it handshaking with? Anything. Lots of traffic is happening from every machine all the time. But some consideration needs to be made. And you can think about it, and if you want to tell somebody that you work with let's use remote logging, just remember the bot equation that is very, very simple, right? Bits per transmission times transmissions per second. That's how expensive your bandwidth is if you want to use remote logging. And then I give you some examples of how much bandwidth is used by basic use cases, right? 64K per second is the minimum streaming bandwidth that you'll see. That's 64K AAC. You're streaming from an online radio service on iTunes, and you're using 64 kilobits per second, 8 kilobytes per second are being consumed so that you can listen to podcasts. More likely, you're doing like 192K per second. That also is just an audio stream. That's like an MP3 stream that's worth listening to with music on it. So if you're listening to web radio, if your customer is listening to web radio on their phone, they're using that much bandwidth. And then the last three are for streaming video, which we do a whole lot of now. If you didn't notice, the internet got really, really big all of a sudden, and it's packed full of streaming video content. 4,500 kbps is a 1080p YouTube stream. 2,500 kbps is 720p, and 400 kbps is the cheapest one, 240p. All right, so this is how much bandwidth an application uses that uses bandwidth. How much does an application use that is improving your software product quality? Can we do 6.4 kbps? So back to baud, all right, bits per transmission. Send a log message to Loggly that says, I turned on and I am device ID 5 and it's 7 o'clock, and actually Loggly does your timestamp for you, so you don't even need to worry about that. It's probably going to be like 100 bytes or less, right? It's the length of the string that you're sending plus some HTTP overhead, which is actually ample, like 100 bytes or 150 bytes per HTTP transmission are unavoidable. Okay, so if every transmission is 200 bytes, let's just call it all HTTP overhead. If every transmission is 200 bytes, then you can send 4 messages per second and use 1/10 of the bandwidth that a single low-grade audio stream uses. So if you've got 10 devices, you're using one crappy audio stream. 100 devices is 10 crappy audio streams. But that's the lowest end. Like, remember that a 1080p stream is using a huge amount of bandwidth compared to that. And so for every 1,000 devices that you connect to the internet, maybe you're using a 1080p worth of video stream, maybe 10,000 devices. And it depends on what your application is. Certain applications log more, other applications log less, which is what we're going to get into next. This slide is to talk about Loggly. There's a button hidden under my thingamabob here. Loggly is the tool that I recommend for doing remote logging because they've already thought of the edge cases. They've already given you brilliant powers of reflection into your log data. So the punchline is, you write an application, you point it at your Loggly server with an API key. When you sign up for Loggly, they give you this API key. And logging is as easy as typing in like log01.loggly.com/inputs/ paste my API key, .gif, message equals hello me, enter. And now that has gone into this string dump on the internet that you can log into and read that has a free tier that will cover all your needs before production. The free tier, you don't need anything more than the free tier until you get over like 100 devices connected on the network. Super easy to use. And then the thing that you need to remember is that all the data that you push should be in JSON format. You make a little JSON packet and you send it up to Loggly. And Loggly uses CouchDB or MongoDB or some other radical NoSQL database on the back end, and it indexes everything that you send according to those JSON keys. And so if you carefully construct all your messages to have the keys that you need, you log into Loggly and you say, show me the results from my CEO's device. Show me the results from all the devices that are located in Seattle. Show me the results from all the devices that are in a downloading state. And it immediately drills down into the domain that you need, even when you've got 10,000 devices logging there. It's secure. It's easy. Remember, you can use GET requests or POST requests. It's always trivial. It's scalable. They will handle 100,000 devices or 10 devices trivially. Like, you won't even notice that anything happened. Livetail is a cool little technology they have now that you can use from the web or from the command line, where you essentially type in Loggly Livetail and you give it the API key, and it gives you a real-time stream of all the logs that are coming into the system. And you can give it, you can grep that stream in advance, essentially, and say, Loggly Livetail my CEO's phone. You can be like, all right, boss, you're going to reproduce that bug? All right, I'm watching your bug in real time. I see you hit the button. Yep, I see where it crashed, and I see where the error line is, and I fixed it for you. You don't even have to look at the web interface to do it. So Livetail's great. And then search is the big killer feature that makes Loggly powerful. This product isn't about demoing Loggly. I'll demo it a little bit, but I'm not really selling Loggly. I don't work for Loggly. I've only been paid a little bit of money from Loggly because I get so excited about them. I'm more interested in logging. If somebody did it better than Loggly, which is unlikely, I'd switch. So this slide's not about Loggly. This slide's about logging. I've been ramping and harping about what logging is and how important it is, but I haven't told you what to do. Logging, I think I'm going to sit down now. Logging is storytelling. It's storytelling about a state machine in the sense that your computer program is a state machine, whether you did that on purpose or not. It always is a state machine. The only thing that a computer program can be is a series of nodes connected by edges. Okay, and that's what debugging needs to grow into. It doesn't matter what the content of your stack trace is. It doesn't matter what you can see in GDB and what your local variables are. It matters what state your program is in and what data came into that state that led it to transition into another state. Okay, this is like functional programming, right? Local data and properties of objects and relationships of objects is just a spaghetti mass of madness. Computers are state machine executors. That's what your CPU does. That's what your operating system does. Doesn't matter what you ever write. It's a node connected to another node by a series of edges. And that in the full context of that, on the Internet of Things with 100,000 devices, it's this vast, vast, vast tree of one device at one state with data coming in from another state. So what you want to log is, you want to log when your application enters a state. And you want to log what information indicated to the application it should go into that state. All right, and that's the punchline. That's the thing that you can internalize, and when you're done writing your program, you can, well, hopefully you've already thought about what states it can be in. But when you're done writing your program, you can put log statements in there that will reveal what mode it is in, okay? Let me see what's on the next slide. I'll come back to this, but I want to keep talking about state machines for a moment longer. If I had a whiteboard, I'd use that. Okay, I will. Depends, there is. Turn, turn, turn. I'm going to turn off screen share briefly. Or rather, I'm going to, yeah, that's right. I'm going to turn off screen share briefly just so that my recording gets the full video, so this is visible at all. So a state machine, harping on state machine, but my last like 3 years of engineering have been home runs that involve state machines one after another, so I still am passionate about that. All right, so imagine that this is your program, and that these are the things that can happen. Okay, and when you draw a state machine, you put this little arrow on it that says this is the first state, this is the beginning state. Okay, so maybe the user presses log in here. Maybe the user presses listen here. And then this is the login screen. This is the listening screen. Okay, and this is the kind of information that you want to log. First of all is you say, I went into this state, and you broadcast that out to the world. And then if the user presses a button, you say, the user pressed a button, and that makes me want to go into this state. Let's just call it 0 and 1 for easiness. But after the user pressed the button, I went into state 1. And then the whole tree works that way. The user did something. The server told me something, and I went to another state. And so this node, this transition is what gets logged. Except for one more thing. There's another part of application state that I haven't referred to yet, and it's the reason why I wanted to draw this picture. Okay, this is the state that people are usually referring to when they talk about my application state, and it's a state you need to be careful about. It's a state that you should not be making decisions about in your program's execution. And that's the state over here that says, this is my IP address, this is what device I am, this is what color I am, this is what the user decided they wanted for notification services. Okay, and this is called global state, right? The most bugs that happen in programs are because of the use of global state for logic flow, right? You don't look at your global state and say, what should I do in my program? And then modify your global state. You try to set this global state and you fix it. And it stays that way as much as it can without changes. All right, so this global state goes out with every one of your log messages. Because this global state allows you, when you get into Loggly, to reproduce any configuration of machine that you need, right? Somebody says, oh, I had a bug and it's only on Google Nexus 5X, right? So we see it on Nexus 5X, we don't see it anywhere else. This state helps you get down there. You just say, hey, Loggly, show me all the 5X devices, and then show me all the bad state transitions within them. So this is a log message. You don't always log all of this, right? You could have global state that isn't important, like, I'm not sure I can come up with an example, so I'll keep thinking about that. I'll let you know. Your log message is, IP, device, color notifications, state 0, user press login. And then, when it transitions into state 1, it says IP, device, color notifications, state 1. Red data for state 1 to start, or whatever. So this is what gets logged. You build your log messages so that they say what state you're in, what you're going to do in that state, and user input in particular. And the rest of the talk is about deciding what those log messages look like. Oh no, depending on what platform. Yeah, all right. Well, I'm sickened, and I'm just going to admit it. I brought a big box, no, rather, I didn't bring a big box of cool Loggly swag that they shared with me. I realized that about 20 minutes ago in the slides, and I was like, oh, no! So I'll bring it to Galvanize and drop it off. And if you guys sign up for my mailing list or whatever, that's what I'll do. I'll put it on LinkedIn. I'll say, hey, remember that Loggly swag I forgot to give you? It's at the front desk at Galvanize now. Thanks, guys. All right, so general rules of logging. The number one rule is, does it tell a story? Now I'm going to move this dumb thing again. Go over here. And this is an anecdote that I like. Does it tell a story? All right, some of you may or may not have played a game called Dungeons and Dragons in your life. And Dungeons and Dragons is a creative storytelling game. And there are tools that dungeon masters use when they create stories in Dungeons and Dragons that involve storytelling flowcharts, where they say, you know, we have a world, and there's a character named Mary, and Mary tells a story. And after Mary tells the story, the characters learn about the evil villain that's coming, right? And you could ask any novelist, how do you draw your flowchart of what your story looks like? And there is one, right? There's a state machine that describes the story that they want to tell. So if you build your log statements right, you can bring up Loggly for a specific device and have it talk to you. It's telling you a story. I turned on. All the data was there. And then I loaded my first song. And then the user pressed pause. And you can read through it and you can recreate. If you've logged perfectly, you can actually recreate the state of the device, like in your mind and in the code flow, as though you had a stack trace, as though you had GDB. You can read through it, go, yep, and then it sent this one, and then it sent this one, and I know every single line, and it makes perfect sense. It's a story that's been told to me. Log user inputs. Number one, the most important thing to log is that the user said something to your application, because it's really the only thing that matters, right? The user never cares if your computer has trouble with its back-end system. Like, oh, you know, I tried to talk to a remote system. A computer argued with me, user. You know, shut up and do something interesting. I don't care whether computers are arguing. I do care if I try to scroll and it doesn't work. I do care if I press a button and it goes up and down and nothing happens, right? So every time the user sends some kind of input, I want to tell my remote service the user's trying to control the app. And then the next message that happens should be, and I handled the user's input. And if you don't have that perfect mating, then you know you have a bug. System broadcasts are notification events that come from outside of your state machine, right? Because there's 10,000 state machines outside of yours that are all executing, that actually control the execution of your program. And so if you get some kind of notification like network up and down, if you get some kind of notification like disk connected or I got unplugged, that's the second thing you want to see in your remote logs, because that's the kind of thing you can't anticipate, right? That's not inside of your state machine. Even if you read your code, you wouldn't know when that message happened. Authorizations and sign-ins need to get logged because they're error-prone and they're exceedingly frustrating. So you need to pay attention to when the user is trying to pass their credentials. Being careful about logging those credentials, of course, but that you need to know that it happened. You need to be able to tell the person on the phone, oh, I saw you log in, and it said your password was wrong. You know, try a different password. API requests, again, are your state machine reaching out to the outside world and coming back with a result. So you want to log those events, and then you want to log heavy stuff. If you're doing face recognition, if you're running artificial intelligence, if you have to write 10 megabytes to disk, don't log within it. Don't say, I wrote a block, I wrote a block, I wrote a block, I wrote a block, because now your signal to noise ratio has gotten bad. Just say, I'm about to do something risky, and here's how risky it's going to be. And then 8 seconds later, you log, I successfully did the risky thing, and I'm moving on to the next task. Don't log in loops. Sometimes you have to for debugging purposes. Please do. I mean, write the logs that you need to do to get your code written, but don't leave that in there. Don't fill Logly up with nonsense, because then you will not reap the benefit. You will not be able to tell your CEO, I found what line the problem was on, because there was nothing in here except for meaningless statements, which is pretty much all that this is. Don't log redundantly. Don't say, for example, the user pressed OK, then I ran the OK press function, then I evaluated the OK press function should tell me to go to state 1, then I activated the state 1 state, and then finally state 1 says, here I am. You don't need to stack up decisions. You log one time to enter the state. You log one time for dangerous operations. You log one time when you get a system broadcast. And you log one time when you cross the node, you cross the edge into the next state. And using that information, you have total knowledge. You can read the log and reproduce what state your machine was in. Log noise, I mean, don't put gimmicks in your logs. Don't tell jokes in your logs, because your log is your state. It's the second most important thing after your code. So, don't fill it up with junk, or you won't be able to fix it. Those are the generalized approaches to logging. Let me check the time. What is it? 11 o'clock? I think I think we're fine, actually, because I still have 30 minutes before you guys have had it with me, right? This is supposed to be a long talk. And I'm not going to talk for 30 more minutes. If you have questions, I'll quit earlier. Otherwise, I even have a little software demo after this. And this is the very last bit of the presentation, platform logging. And this is the hard part. This is why my expertise with 7 years of doing IoT and distributed micro kind of engineering, full stacky stuff, qualifies me to give this talk, more or less. Because I go into a hardware engineering team and I say, you guys should be remote logging. And they're like, what are you talking about? I'm writing firmware that runs on a tiny PIC. I'm like, is it connected to the internet in there? Well, yeah. I mean, it's not interesting if it's not connected to the internet, right? Who writes a piece of software that's not connected to the internet? No one does, more or less. Unless you work for the, well, no. If you work for the NSA, you're definitely connected to the internet. NASA, maybe you're not connected to the internet. Anyway, so almost in all cases, everybody should be using this service. And I am the jerk at work that says, you should use remote logging. You should use remote logging. Oh, you're working on a tiny little system that doesn't have enough intelligence to make an HTTP request? I'll teach you how to use remote logging. Okay, so logging for Internet of Things. Internet of Things is the hilariously globalized term that refers to an object that's got a built-in wireless access point and a mobile app and a server that enables them to handshake. That's really the essence of Internet of Things, because you can't take ownership of an object until you've connected it to your own wireless network. So this first step is WAP configuration, okay? You get a Nest, you get a cool camera, you get a sprinkler control system, you even get an Alexa. And the first thing that you do is you plug it in, and then you hold down the power button until it flashes WAP mode, and then you get your phone out, and you teach your wireless access point located inside of your thing to connect to your own network, so that it becomes an object on the Internet of Things. Before that, it's just an object in a plastic package. And that configuration needs to be carefully tracked, because it's always error prone. It's the most dangerous part of your application flow, because if you get it wrong, you have a very expensive piece of garbage that your customer just bought, right? I just bought a $300 sprinkler control system with a wireless access point, and I just want to throw it away, and I'm pissed. So not only do you need to log this process of doing wireless access point configuration, but your phone needs to relay the part that comes before the device has connected, because it's not connected at first. It comes out and it can't remote log, and it needs to send those messages to somebody. And so you hold down the button on and it turns on wireless access point mode, and it should be buffering data. The person who wrote that wireless access point configuration button press step should be buffering some data. And as soon as your phone connects to it, and it says, I'm a wireless access point and a device just connected to me, it should tickle an access point, an endpoint inside of your phone, and deliver that data to be logged. And so your phone says, now I'm going to relay, and I'm going to come to this a few times. When you're working in limited domains, you have to have a machine relay log messages for the machine that's in the limited domain. And a lot of people who are C programmers and firmware programmers feel like that's really onerous. Like, what are you talking about? Like, I'm just writing 100 lines of C code that run on a tiny little microprocessor just to turn on the wireless access point. Why do you want me to log this stuff? Because otherwise, you don't know what's gone wrong. And these guys write bad code, just like we all do. I'm not criticizing anybody in particular. They write code in their tiny little integrated circuit that fails. And then unless they are sending these log messages, you know, a failure in a tiny little piece of firmware responsible for handling a wireless access point configuration is actually a super hard bug to solve, right? You can tell when the bug gets reported how long it's going to take by the tone of the voice of the C developer. Like, yeah, that could be a pointer mistake in the data stack for that. Yeah, okay, well, I'll be looking into it. You know, all right, so anyway, authorization, user inputs, like with a Nest, turning the knob. The user touched me. Oh, and they dragged me. They dragged me 34%. And now I've set myself to 62. Like, you want to log that stuff because that's the life of the device. And then finally, there's a lot of IoT devices that don't actually have wireless access points, that are BLE or Bluetooth or some other low energy communication method. And they should expect to be relaying log messages through the device that does have an internet connection, because there's always a chain of low energy transmission device, Wi-Fi connected device, server management, user accounts, and so on. And so you can actually, no matter what you're going to build, you can come into the point of view that if you don't have a wireless connection to the internet, you know somebody who does, and you should be ready to relay messages through them. Firmware is the next one. Scarcity is the word. I was working with a guy a few months ago who told me he had 30 kilobytes of RAM for compiling his whole application for controlling like a servo on a, some kind of, it was like a servo camera. I might actually know what it is, but I don't want to leak any user secrets. It was a servo with a 30 kilobyte controller for it. So firmware devices in general need to have some kind of relay. And you can start the project saying, I will write you a nice little log relay server so that when you write your firmware code, you can send messages to the log relay server and we can all agree about what happened inside of your program, and you'll like that. The last item on here is lookup. Okay, some devices, some firmware devices are so pathetic that they don't even have enough data available to have log messages, right? Oh, you want to send 50 different log messages and 35 characters long each? Like, that's the majority of my available storage. So those log messages you could store as an integer, and you have a lookup table on your relay machine that knows what that log messages means. Because a lot of the time with a serial port interface, with some kind of serial connection that a hardware or firmware engineer is using, all they're doing is passing integers back and forth anyway, right? They're just passing integers on a serial line. So a log message that says, my firmware turned on and I'm waiting for my next message could just be relayed as 0, 6. And that goes across the serial line. The relaying device sees 0, 6, and then sends a message up to Loggly that says, my firmware booted up and said it was happening. And that helps. If you get into the habit of using the system, every time you've got a piece of software that your people are writing that you have not put into the remote logging environment, you'll grit your teeth. And you'll not be mad at them. You'll not be like, you know, if only these jerks would figure out how to use my log relay system because it's the best. You'll just say, when my code crashes, we fix it. And when his code crashes or her code crashes, we scratch our head and hope that the muses of software bug fixing will swoop in and make the bug go away. Mobile devices, scarcity is the big concern. And it's the biggest pain with remote logging, even worse than doing firmware or wireless access point relaying. I feel like maybe it's on its way out, okay? 5 years ago, the big thing was, you know, 5 gigs is as much data as anybody has per month. And a student of mine told me that 6.4 kilobits per second for 24 hours is 550 megs. Okay, so, you know, you're going to use up 15 gigs of data per month using logging continually on a mobile device. So it still matters. And here's how you resolve it, okay? When you're logging from a mobile device or a progressive web app, you know whether you're connected via 3G or rather LTE or internet. And you control your modes, okay? And there's kind of three states that you can be in. I'm fully connected. I'm logging every transition in my state machine. I'm not going to sweat it because I really want to know how the program works. I am connected to LTE. I'm going to buffer my transmissions, okay? And Loggly supports a thing called bulk transfer. And you can say, I'm just going to keep data of these log messages without sending them because I don't want to use up my users' bandwidth because it's something that's not important. They're listening to music. We don't need to use up their bandwidth because they're listening to music. And then finally, if it is important, if this is a map navigation application, or if this is some life-saving device, go ahead and log. Like, use the data, because it's more important that you fix issues with your software than you preserve your users 550 megs a day. Servers are huge. Typically, you just assume that bandwidth is unlimited. You log your application as this. And the thing that's extra that you need to know is that your server has tons of more state involving the machine itself, what version of Ubuntu it is, and what libraries you've got, and all this other stuff that you also want to log. And Loggly has crazy libraries for this. You can modify your system's version of syslog so that everything that comes through syslog gets sent to Loggly as well. And so when you're doing server logging, simply remember that you have a meta case and that you can actually log anything on the system. Micros and containers is when I gave up any thought of other methods of debug. Now that we're in the age of Docker, you can't debug your software with any method at all except remote logging, right? Because if you use a microservice, you are going to spin up a Docker container. It's going to have all this lifecycle stuff involved with it coming alive. It's going to execute a small amount of code, and then if there's a bug, it's going to get destroyed. It's going to be removed from the execution environment, and there won't even be a record of its state. There won't even be a message. You might be able to log into Amazon Web Services and see it say, there was a seg fault in your crappy Docker container, and I threw it away, because I'm not going to keep 100,000 seg faulted Docker containers for you to debug. So in the age of micros, you log the bring up and the tear down of a container. Inside of your logging service, you want to say, somebody created me. I have life. I have breath. Here's who I am. Here's what my Docker ID is. Here's all the other identity messages that I need to have. And then I'm done. I did the work that I was hired to do, and now my life is being taken from me. Goodbye, sweet world. And you should be able to see that in your logs. Look, it activated my container. It ran me on a micro and threw it away. Okay, and then timing matters here too. What time did your Docker container get created, and how long did it take? How long did the work take? Because in micros, something that you have to struggle with is, how much resources do I actually have right now? Because the server claims that I've got this much power, but I actually don't. This is the last slide, you guys. Thank you for your patience. Professionalism. I'm just going to come back to this to end this, because there's been a number of things in my career that I consider to be force multipliers that made me into a better developer. Linux was the first. Mac was the second. That was a pretty quick transition. Switching to using a 4K monitor for my work was the third. Or maybe logging came before it. And remote logging is another one of those, okay? I am 10 times better at fixing bugs using remote logging than without them. And that guy back there, all those slides ago, going like this, like, that's real, you know? Being able to read these messages and fix issues on the spot, it's not just good development. It's not just, I think logging is cool and I think stack tracing is lame. It's that I feel way more professional when I kick a bug's ass on the spot, right? That's the thing that really matters, is I built this logging environment. I saw the bug happen and I fixed it. And it wasn't something that happened in a remote place. It's something that I am selling. Oh, you hired me to build this for you? I'm gonna have you pay me to make a system that will fix all your bugs for you as they come. Logging is the bomb. Thanks for coming, everybody. Any questions? Anything? If you have a few more minutes, go ahead.
Yeah, I kind of have this image of logging in my head from working, I guess, with Log4j. And the thing that really stands out is like setting different levels of logging, right? And
Yeah.
this is an emergency, this is an error, this is just purely info. And we would actually change like a system setting to say how much do we want to log, because it's not realistic to parse everything.
Right.
But I feel like we've kind of moved, talking about, we really want to know how, when we're entering a state, how we exited that state, and we have the bandwidth to just like kind of see everything. So, your mention of progressive web apps and like how strong is that connection kind of makes me think that maybe that model of how do we like tag or classify logs is a little bit differently. So I was kind of curious if you could just talk about like log classification and like what that's like in modern day, especially with remote logging.
That's a super great question, and it's something that I wanted to present in this that slipped my mind. I was thinking about it on the drive down, or thinking about it this morning before I even came. We have too many log levels in general, like info and warning and debug and verbose and then general. It's more than we need. The worst thing about that is that I think we need a couple more. We need one for am I in 3G mode or am I in Wi-Fi mode? And we need one for, well, maybe we don't need that. Okay, maybe we separate logging down into state messages, network status messages, and critical messages, all right? And we assume that everything is logged all the time because it's either going somewhere remote or it's going somewhere local. It's being dumped into a file. And then if the state of the system changes so that we are now in 3G mode, we'll reduce the log level so that we see a little bit less information. Maybe we only see critical stuff when we're in 3G mode. And then, well, so maybe that's it. I'm glad you asked the question because I use log levels intuitively now, and sometimes they're wrong. That's probably the worst thing about log levels is when you classify something as being an info message when it should be a debug message. Debug as a category should just be eliminated, right? You should never have debug messages because they're guaranteed to clutter it up. It's like this slide back here. These are debug messages. And you're responsible for taking these out. You don't depend upon a log level being set. You use these when you are writing the code. When you believe that it works, they're useless, right? It's not helpful. Yeah, I guess that's my status on it. Log levels are a pain, and I don't have a great position. We need fewer. We need to assume that everything is logged. And we need to have log levels that simply disable logging when we're worried about bandwidth, and then can re-enable it when a message has to get through for the sake of stability of the system. That's my opinion.
I have a quick comment on security. I love the response to security questions of a system with bugs is not secure. And so, it doesn't matter if your authorization is secure, if Pops is married data, it's Pops data. So I feel like it's a great answer. If someone says, but what about security? So
yeah.
So the other question I have is about immutable data states and how is it ever feasible to capture the entire diff or the entire state as a whole, as opposed to saying I just want to log a little piece of it using React or ClojureScript or something like that.
Right.
Would that be kind of the end game of remote logging to be able to say I literally have the entire history of this user state?
Yeah, no doubt. And that's what I'm trying to allude to along the edges. What I want to say is that, and if you wrote the right script, if you wrote a sweet enough grep and said, you could look at the logs. In the init state, it would say, here's my general state, here's my entry state. And then from there, I'm going to walk edges, and I'm going to visit new states and modify my global data set. And I could just grep through that and rebuild the application's entire execution, right? If you had built the log perfectly. Now, there's a temptation to log the whole state with every message. And it can make bandwidth more expensive because obviously if you're presenting a user application and they go to an admin page and they've got a table full of logins or a table full of your favorite tracks, that's a huge data set to log that doesn't actually contribute anything. You can see that message at logline and go whoop-de-doo like they like Jay-Z. That's not contributing to my bug solution. Whereas if you log those edge transitions, you can look at it and say they loaded their data set. And if I need to, I can load that data set too. I can step back and see it. I think that there is a possibility that you could capture a few more bugs if you absolutely logged everything all the time. But I think that the majority of the time, this will solve your bugs more efficiently because you don't have to sift through all the noise. And that you start at the edge state, you start at the start state, you see the edges, you know what state the application is in, and you get straight to it. Whereas if you log everything, take for example, instead of just logging transitions, you log the whole state and the history of the state. When you bring the system up, you have to track through this massive string to try to figure out where you are. Thanks.
Thank you.
So I made this funny little app. It never got as good as I wanted it to be because I started a new job. And the plan was to write, so this is a React website that loads the time from the server every 10 seconds and then increments it itself. So you'll see some really, really funny behavior because it's not a real clock at all. It's a messy little bizarre clock. And I'm going to refresh it because my WebSocket fails. I tried to keep it alive indefinitely. And we could actually go back through the logs. And so you can see that it takes the 0 off. That's because it's actually iterating the seconds itself. And then it resyncs. Now it got the real time. And now this is the best part. We give it about 5 seconds, and then it'll resync and go on and do the right thing again. That's because it's talking to a server to do that, and it's logging these messages as it goes. And then on the command line, somewhere, so I told you I use a 4K. I use like 9 terminal windows at once. I put them all up on the screen at the same time. Okay, so this way I can send messages that toggle mode decrements the hour. And then after 10 seconds, it fixes it again. So we can see that happening. And change color changes the background color. So the plan was I was going to get this out and say, look at my cool app. I needed like another hour and a half to build this and couldn't. Look at my app that controls this running on a different screen. Try to hack my funny IoT thing. It's got a server. This is the thing. This is the phone. Hack it, sniff it, make it do funny stuff, and we'll look it up. And then on Loggly, we can hop on and see this data coming in. Okay, so you can see this all began at about 1700 last night. And it started logging. There are 2,800 log messages sent at 11 p.m. I let it run all night long. So I click on this latest set of bars, and it creates a time window in Loggly. And it's going to show me the server and the app sending messages up. This one says, this is, I think, the server getting the keep alive. Let's see, it's got a tag. Yeah, log all things demo server. So the demo server says the client gave me a keep alive. This one's tag is log all things clock, and this message is not being parsed correctly by JavaScript. That would say message keep alive. Okay, so the point of this demo is so that I could show you all 3 objects serially interacting with each other in a single stream. And so, for example, I get my phone out and I say change background color, and it doesn't happen. Then I can simply go in here, see where a change background happened in the app that was not met up with a change background color inside of the server, and I find the bug on the spot and and fix it. So something that you usually want to do is you want to change your present timestamp to be now, and then every time I refresh this, it'll add new events. 11:25:27. It takes a little while to get in. The messages are sent up to Loggly, and they get indexed in a massive sharded distributed server. And so you don't see them in true real time, but you see them close. See, so we jumped from 27 to then 35, 35, 36, 36. And this is the clock followed by the server handshaking this step by step by step. And then I was thinking maybe I could figure out why my WebSocket closed, but it's hard enough to do that it's probably not worth doing in the last 4 minutes of the presentation. 15 minutes would probably be enough time. And so if my boss called me and said, I'm trying to change the background color on this $10,000 clock you sold me and it doesn't work, give me 15 minutes and I'll tell you why and I'll fix it and send you a new version. So anyway, that's the demo. I love Loggly. It will make you a better programmer. It'll make you fix your issues better. Maybe it's made me into a worse programmer because I know Loggly is holding my hand as I go. So that is all. Thank you so much for coming, everybody, once again.